Hey there, Algebra 2 students, and welcome back to Ms. McGuire's classroom. Today, we are going to be going over Unit 1, Lesson 7. Our topic is slope-intercept form. This should be a review of something that you learned and mastered in Algebra 1. Don't forget to put your first and last name at the top right-hand corner of your notes, along with the period and the date, and make sure that you're writing everything down as we go. So today's objective is I will be able to graph linear functions in slope-intercept form by identifying the slope and the y-intercept. So what is slope-intercept form? Well, slope-intercept form is the form of an equation that looks like y equals mx plus b. So this right here is slope-intercept form. So some things that we need to note, some key information about slope-intercept form is that an equation that's written in this form actually gives you two key features. And those features just so happen to be the slope of the function, of the graph, and the y-intercept. So M represents your slope, and B represents your y-intercept. So whenever we talk about slope, we want to talk about it as a number that's being multiplied by x. M represents multiplier. That's why your slope is always represented with that M. Because mx means multiply m times x, and then you add b, or your y-intercept. So your slope is always m. M equals the slope. Your y-intercept is always b. And whenever you write your y-intercept, you want to tell me it as a point, and you're always going to write it as 0, b. Because to have a y-intercept, the x value of that point will always be 0. And we'll talk about that more when we get into graphing. So for now, that's enough about slope-intercept form. It's when you get an equation that looks like y equals mx plus b. You need to remember that m represents your slope, m represents your slope, and b represents your y-intercept. Let's talk about slope just a little bit more. So slope, you're always going to write as m equals whatever number is being multiplied by x. So m equals will always be out in front of your slope. And we always want to remember it as rise over run. So m equals rise over run. You always want to talk about your rise first. So rise can either be up or down. You can rise or you can fall. But when you run, we always talk about running in the right direction. So rise can be up or down, but when you run, you're always going to run right. So let's look at some equations. In example 1, we're going to talk about 3 equations, and we're going to identify the slope and the y-intercept of each function. So this first equation has y equals negative 2x plus 2. This equation is in slope-intercept form, or y equals mx plus b form. Well, what number is being multiplied by x? What's our m? Negative 2 is being multiplied by x. So our slope is m equals negative 2. Then what's my y-intercept? Well, remember the y-intercept is b, or whatever's being added or subtracted to mx. So in this case, it's 2. But when you talk about your y-intercept, you always want to think of it as a point. So we're going to write it as the point 0, 2. Now look at the equation y equals x. Why don't you give this a shot yourself? Identify the slope and identify the y-intercept. If it helps, think of it in terms of y equals mx plus b. And see if you can figure out what your slope and your y-intercept would be. So what I notice is that y equals x. Well, technically there's a 1 out in front of this x. So that means that my m is 1. My slope is 1. M equals 1. For b, well, you might say nothing's being added or subtracted. Well, what is nothing? Nothing is technically 0, right? So isn't there technically a plus 0 out here? So our b is actually 0. So my y-intercept is the point 0b, or in this case, 0, 0. Let's do one more. Y equals 3/5 x minus 4. Go ahead and identify your slope and your y-intercept. Remember, slope-intercept form is y equals mx plus b. So for your slope, your slope should be identified as m equals 3/5. And your y-intercept is that -4. So write it as a point, 0, -4. And there we go. All right, for the next few examples, we have equations that are not written into slope-intercept form. 6 minus 2y equals -x does not look like y equals mx plus b. So what we're going to do with these three equations is we're going to change them. We're going to put them into slope-intercept form. So I'm going to write y equals mx plus b off to the side so I remember what slope-intercept form is. And slope-intercept form has y isolated on one side of the equation. So I want to isolate this y. To do that, I'm going to subtract 6 to both sides. Then I'm going to divide everything by -2. So I get y is equal to, well, technically there's a -1 out in front of this x. So I have -1 divided by 2, or divided by -2, or just positive 1/2 x. -6 divided by -2 is positive 3. So y equals 1/2 x plus 3. Well, hey, now this is in slope-intercept form. Y equals mx plus b. Well, what's my slope? My slope is m equals 1/2. What's my y-intercept? 3. So it's the point 0, 3. Why don't you go ahead and try this next example on your own. 5y plus 10 is equal to -2x. Here's a hint. Solve for y and put this into slope-intercept form. So what you should have done is subtracted 10 to both sides first, then divide everything by 5. So y is equal to -2/5 x minus 2. So what's our slope? What's being multiplied by x here? Our slope is m equals -2/5. And then what's our y-intercept? Our b would be -2. So our y-intercept is the point 0, -2. Now let's do this one more time just for a little extra practice. I want you to put y minus 5 equals -1/2 times x plus 4 into slope-intercept form. So this time you need to solve for y, but you also need to simplify that right-hand side. Go ahead and give it a shot. So the first thing I would do is actually distribute this -1/2. So y minus 5 is equal to -1/2 x minus 2. Then I would add 5 to both sides. So y is equal to -1/2 x plus 3. So now we can clearly identify our slope. This is in y equals mx plus b form, or it is in slope-intercept form. Our m is m equals -1/2. Our b is 3, so our y-intercept then is 0, 3. So that's how you use slope-intercept form. That's how you put equations into slope-intercept form, and then identify your slope and your y-intercept. Now we're going to practice graphing using slope-intercept form. So in example 3, we're going to take this function that is written in slope-intercept form. We're going to identify our slope and our y-intercept, and then we're going to graph it using those two things. So remember, before we get started, we want to make sure that we correctly label our graphs. This is just a friendly reminder that if your graphs aren't labeled, I will not grade them, and you will get automatic zeros. So make sure that you have your graphs labeled, please, so I can grade them. So get your X and Y axes labeled. We want all of our dashes. And then you want to label every other number on your scale. So I'm just going to label the evens. And there we go. So this is how you graph using slope-intercept form. So our function is f of x equals -3/2 x plus 1. Well, remember, f of x is just function notation. So really this means y is equal to -3/2 x plus 1. So if you think about slope-intercept form, what's being multiplied by x in our equation? That -3/2. So that must be our slope. And then what would our y-intercept be? Well, b is 1, so our y-intercept is 0, 1. So our slope is m equals, sorry, what was that? -3/2, and our y-intercept is 0, 1. So the first thing you're going to do is you're going to graph your y-intercept. So your first step is to graph your y-intercept. So graph 0, 1. Then you're going to use your slope to find some more points on the graph. So you're going to use your slope second. So our slope is -3/2. So remember, slope is rise over run. So if your slope is -3/2, your rise is -3. So your rise would be -3, which means go down 3. So 1, 2, 3. 1, 2, 3. Then you're going to run 2, and always run to the right. So 1, 2. Now do it again. Go down 1, 2, 3, then run 2, 1, 2. Now find some points to the left of your y-intercept. So because we're going in we need the other half of this graph, you're going to go in the opposite direction. So if you go up 3, 1, 2, 3, you're going to go left 2, 1, 2, 3, over 2. So you can see we still have our straight line, and then you just draw your line and put your arrows underneath. So make sure your graph extends across your entire coordinate plane, please. All right, now let's describe our domain and our range. So my graph extends to the left and to the right forever, which means there are no restrictions on our domain and range. So our domain would include -infinity to infinity. And our range also includes -infinity to infinity. What about our end behavior? So as x approaches negative infinity, y approaches something. And then as x approaches positive infinity, y approaches something. Well, to the far left here, as our x's decrease, our y's are increasing. So our y's approach positive infinity. Then to the far right of this graph, as our x increases, our y's are decreasing. So as x approaches positive infinity, the y's approach negative infinity. And we're all done with that example. So now I want you to graph f of x equals negative x. I want you to tell me the slope, the y-intercept, the domain, the range, and the end behavior. So you're going to press pause, graph this, and then press play when you're ready to check all of your answers. So this is the graph that I got from my solution for graphing y is equal to negative x. So what I noticed is that there's a -1 being multiplied by x, so my slope is -1. I also noticed that nothing was being added or subtracted to negative x, which means that b would have to be 0. So I know that my y-intercept, which I'm realizing I wrote incorrectly here, should be 0, 0. So when I graphed it, the first thing I graphed was my y-intercept, 0, 0. Then for my slope, because it's -1, and technically -1 is over 1, so my rise would be down 1, or my fall would be down 1. Then my run would be 1. So I went down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, etc. And it started to form the shape of this line. Then I just connected all of my points, and I've graphed my line. And I made sure that my line went across the entire coordinate plane. From there, I was able to identify my domain. So for my domain, I noticed that my x values extend to the left and to the right forever. So my domain includes -infinity to +infinity. For my range, I noticed that my graph extends in the negative y value forever and the positive y value forever. So I have -infinity to +infinity. So for my graph, to the far left, it's extending upwards. So as my x values decrease, my y values increase. So that means that as x approaches -infinity, my y's approach +infinity. Then to the right, the far right of this graph, my x values start to increase while my y values decrease. So that means that as x approaches +infinity, y approaches -infinity. So once you're done with your notes, you can go ahead and get started on your homework, and I'll see you back in class in just a little bit.